Here we're going to be doing some algebra proofs. So we're essentially going to be solving for x the way we've done things forever, but we're going to add our list of reasons so that we can set up these two-column proofs. So we're going to start off on this left-hand side with a given statement. So given 3x plus 12 equals 8x minus 18, we have that in our first statement. Our reason is that it's given. They gave it to us, so we're going to start off with our given statement. Our next piece, to get down to 12 equals 5x minus 18, we had to subtract 3x from both sides. So that would be, and I'm going to shorten this up, that would be the subtraction postulate of equality. I'm going to use SPO for subtraction, APO for addition, MPO for multiplication, and DPO for division, postulate of equality. We have those on the list of reasons. Okay, we've been doing this forever. They're actually called the postulates of equality. So now to get down to our next step, 30 equals 5x, we have to add 18 to both sides to cancel it out over there. And what makes it the postulate of equality again is if we do it to one side, we have to do it to the other. Okay. Then we finish up. We've got multiplication going, so to get rid of the multiplication, we divide by 5, which is our division piece. And because I did it to one side, I have to do it to the other. That's our postulate of equality piece, which gets us down to x equals 6, which is what I was trying to prove. Okay, that's all we're doing. We're giving the reasons to show what we did in the step before to get down. So like in this step right here, this red step, it's what I did to get to that point. So I had to use subtraction postulate of equality to get to that point. Okay, so just wanted to make sure we covered that right there. We're going to go on ahead and do this one as well. So again, we have our given statement. Always going to start off with a given statement. So you can pretty much assume that's our first reason every single time. Going forward, okay, to get 3k by itself, we have to subtract 5, which is our subtraction piece again. And then we have to do it to both sides because if we do it to one side, we have to do it to the other. That's our postulate of equality piece. And then again, we were multiplying, so we have to divide, division. Because we do it to one side, we have to do it to the other, is our postulate of equality, which gives me k equals 4. Okay, so again, nothing crazy. We're just working these things down the way we always have, using our postulates of equality and any other steps that we might need. Okay, now we're actually going to work these things out. So we'll start off with our given statement. Okay, our given statement says negative 6a minus 5 equals negative 95. Now my first step, I want to get my a's by itself. So if I want to get a by itself, then I need to add 5. So it's going to be addition. I add to both sides because I added to one side, so I have to do it to the other. That's our postulate of equality, which gives me negative 6a equals negative 90. And then to get rid of my negative 6, because I want to get a by itself, that's our division piece. And because I did it to one side, I have to do it to the other. That's our postulate of equality piece. So a is going to equal positive 15. Because negative divided by negative, okay, is going to end up being positive. 90 divided by 6 is going to give us 15. Sorry, I don't have my calculator up. We'll be sure to do that going forward. On this last one, we have our given statement as 3 times 5x plus 1 equals 13x plus 5. That's our given statement again. My first step is I need to distribute, okay? So I'm going to use the distribution property to give me 3 times 5 is 15 Let me use that a little bit higher. 15x plus 3 equals 13x plus 5. Okay. I want to get my x's by itself. Okay, so I want to move my smallest x over, which is going to be 13. So I need to subtract 13x from one side, and because I do it to one side, I have to do it to the other. So I end up with 2x plus 3 equals 5. Because I did it to one side, I do it to the other. That's my postulate of equality again. Now I want to get x by itself, so I have to isolate. I have to subtract 3. So that's, again, the subtraction. Doing it to both sides, postulate of equality. We end up with 2x equaling 2. And then to get x by itself, I need to divide both sides by 2, which means I'm going to use the division postulate of equality to end up with 2 divided by 2 is 1. So I have gone ahead and proven that x equals 1 after my given statement.